Students, welcome to the physics class. In the last class, we had already discussed about the universal law of gravitation. According to the universal law of gravitation, the force of attraction between the two objects is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So you already know that equations of that the universal law of gravitation, how much of the force which is acting on it. So we will we got the F is equal to G into m1 m2 divided by what is that, r square. So this is the equation what we got in this universal law of gravitation. Now what is the unit? And what are all the things? Let us consider. So the G is considered as a what here? The constant. This is considered as a what here? The gravitational constant. Its value is 6.67 into 10 to the power of minus 11 Newton meter square per kg square. So we can able to calculate that gravitational constant like the gravitational force of the earth. The gravitational force of the earth is nearly 9.8 meter per second square. In the same manner, the gravitational constant for each and every the body is equal to 6.67 into 10 to the power of minus 11. So by calculation, we can get this particular value. That calculation part we will discuss in the later stage. Okay. Then how we will get to the unit for the universal gravitational constant? Change the subject of the formula. So here we have the one thing, that is the G is equal to, that is F is equal to G into m1 m2 divided by r square. I change the subject of this formula. G is equal to F r square divided by m into m. Okay. If the unit of a force is Newton and a meter mass is in what here? The kg. And the d, instead of d I had taken r here, okay, distance is in what here? The meter. Then the unit of G is equal to F r square divided by m into m. So therefore the unit of force is in Newton. So this is the distance is in meter square, and this becomes kg into kg, it becomes kg square. So this is the unit of what here? Gravitational constant. Now we have a relationship between the what and what here? The third law of motion and also the Newton's law of gravitation. So according to the third law of motion, every body, every object exerts an equal and opposite force. You already know that F1 is equal to the minus of F2 in the last chapter. But according to the Newton's laws, the every mass in the universe attracts the every other mass. Okay, there is an attraction is there between the what here? The masses. And secondly, in case of freely falling body, the stone is attracted towards the earth. It means that earth attracts the what here? The stone. In the same manner, but according to the Newton's third law of motion, the stone should also attract the what here? Earth. It is actually true. Okay, it is a true, even the stone which is attracts the what here? Earth, but which is a very small acceleration. You please see, it is a true, the stone also attracts the what here? Earth with the force of what here? F is equal to ma. But due to the very less mass, the acceleration of the stone is 9.8 meter per second towards the what here? Earth. But acceleration towards the what here? The stone is nearly 1.65 into 10 to the power of what here? Minus 24. It is a calculated value, which is very, very negligible. So we can't able to feel it. So this is the relationship between what and what here? So the gravitation and also what is that? The third law of motion. So then what is the importance for this the universal law of gravitation? The universal law of gravitation, it tells you about the force that binds us to the what here? Earth. And also another important thing is that the motion of the moon around the earth is due to what here? this gravitation. The motion of earth around the sun is also due to the what here universal law of gravitation, and the formation of tides is also due to what here a moon and also the sun's attraction. So these are the importance of the what here universal law of gravitation. Thank you for watching the video. Thank you very much.